Let's take a look at another question. For example, let's check question 20. Question 20 says, well, solve the given differential equation. Here we have 2x squared, the second derivative of y, plus 5x y prime plus y equals to x squared minus x. Well, first of all, let us solve this differential equation for the homogeneous part. So for the homogeneous part, we have 2x squared, the second derivative of y, plus 5x y prime, plus y equal to 0. So we're using y equals to x to the m and do the substitution. We get y prime m x to m minus 1, and the second derivative equals to m minus 1 x to m minus 2. Let's do the substitution. We get 2x squared m minus 1, and then we have x to the m plus 5x, and we have y prime, which is m x to m minus 1, so eventually it becomes x to the m. And finally, you have plus y, which is x to the m equal to 0, factoring out x to the m. So here you have x raised to m minus 2, then you get x to the m, you get 2m squared minus 2m plus 5m plus 1 equal to 0. So your auxiliary equation is 2m squared plus 3m plus 1 equal to 0. So as you can see here, you can just use grouping. 2m squared plus 2m plus m plus 1, and you get 2m m plus 1 plus m plus 1 equal to 0, and then factoring out m plus 1 gives you 2m plus 1 equal to 0. So m is just -1, and m is equal to -1/2. You have two distinct solutions. It means that yc is c1 x to -1 plus c2 x to -1/2. We have our y1 and we have our y2. Now let us write this guy in standard form. Be careful about your x. You're dividing by 2x squared. So this guy becomes the second derivative of y plus 5 divided by 2x y prime plus y over 2x squared equals to, so here you have 1/2 minus 1 divided by 2x. This is our f of x. Very well. We need to find u1 and u2. So let us find the Wronskian of y1 and y2. The Wronskian of y1 and y2 is equal to, well, here you have x to -1, negative x to -2, and x to -1/2, its derivative -1/2, x to -3/2. So this determinant is equal to, very good, we get the multiplication -1/2 x raised to -3/2 minus 1 -5/2 plus x raised to -2 minus 1/2, you get -5 over 2. So if you simplify this, you get 1/2 x to -5/2. This is the Wronskian that we have. u1 is equal to the integral w1 divided by w. Let us find w1. w1 is 0, and your f, which is 1/2 minus 1 over 2x, and you have y2, which is x to -1/2, -1/2, x to -3/2. So this determinant becomes, this is 0, and here if you just distribute this, you get negative x to -1/2 minus 1 over 2x, which becomes -1 over 2 square root of x plus, well, here if you just bring this guy to the denominator, you get 1 over 2x square root of x. So this is my w1. Now you have to plug that into the integral and take the integral. This guy becomes the integral of -1 over 2 square root of x plus 1 over 2x square root of x. And remember that your Wronskian was a half x to 5 halves, or just you can write it as 2x to 5 halves dx and start taking the integral. Let me erase this part. We need more space. So this integral becomes the integral of, well, here you can cancel out 2 and 2, -1. And here you have x to 5 halves divided by x to a half. And here you have plus x to 5 halves divided by x to 3 halves dx. This has become the integral of -x2. So if you do the subtraction, you get 5 divided by 2, or just minus a half, which is 4 over 2, or just 2. And here you have plus x dx. This guy becomes -1/3 x cubed plus a half x squared. What is this? This is your u sub 1. Okay, very good. So let us write down u1 here, and then we move on to find u2. X cubed -x cubed divided by 3 plus x squared over 2. This is my u1. Well, to find u2, you need to follow the same process. u2 is the integral w2 over w, where w2 is, well, here you have, very well, so our y1 is x to -1, so its derivative -x to -2, and you have 0, and your f of x, which is a half, minus 1 over 2x. This guy becomes, well, here you have x minus 1 divided by 2 minus 1 over 2x, or a half x to -2. So this guy becomes the integral of w2, which is 1 over 2x minus 1 over 2x squared. And here you have your a half divided by a half, so you get 2 x to positive 5 over 2 dx. Let's find this integral. Let's erase this part of the board. And this guy becomes, well, the integral of 2 and 2, they can cancel out, x to 3 halves minus, let's see, x to a half dx. Very good. So this integral, if you add 1, you get 5 over 2, so 2/5 x to 5 over 2 minus 2/3 x to 3 halves. This is my u2, so let us write down u2 here. 2/5 x to 5 halves minus 2/3 x to 3 halves. We found u1 and u2. Now we can easily write the particular solution. The particular solution, y sub p, is equal to u1 y1, so x to -1 negative x to the third divided by 3 plus x to the second divided by 2 plus y2, which is x to negative a half times 2/5 x to 5 over 2 minus 2/3 x to 3 halves. Let us distribute this. Yp becomes, well, negative x squared over 3 plus x over 2 plus 2/5 x raised to 2 and minus 2/3 x. So can we simplify this? Yes, here we have like terms, here we have like terms. So y sub p becomes, let's see, we have 2/5 minus a third x squared, and you have plus a half minus 2/3 x. So just following the algebra, this guy becomes 1 over 15 x squared, and here you have minus 1 over 6 x This is our particular solution that we have. So now if the question says, hey, what is the general solution? The general solution is the sum of particular solution and yc. So y becomes y sub c plus y sub p.